Hello. So we're now going to do some example problems from section 2.3. So long division. Key thing when you're setting this up, this is divided by this, which means this is going to go on the outside. But I'm going to rewrite it in standard form, meaning it's going to have to be the x squared minus 2x plus 3. And then going into, this is not in standard form, so the x to fourth comes first. But it's also missing a cube term. Don't forget to write that in. It's got an x squared term. It doesn't have an x term. There's a lot of stuff this thing doesn't have. It's kind of disappointing. Plus 1. Now, I have not left myself enough space, so I'm going to go boldly move this thing down a little bit. But then we just follow through and make sure to line stuff up. So, lead coefficient, x squared times what is x to the fourth? X squared. Don't forget to put that x squared here. If you do this correctly, you'll run out of spaces, and then you know you have a remainder. So x squared times x squared is x to the fourth, like we hoped. Negative 2x times x squared is negative 2x cubed. 3 times x squared is 3x squared. I like to put parentheses around it when I subtract, so I don't forget. This goes away. This minus a negative is a positive 2x cubed. 3 minus 3 is 0. I'm going to write a placeholder 0x squared, and then I have to have a 0x because I have to bring this down. Then on to the next. X squared times what is 2x cubed? Well, I need a 2. I need another x. Then I distribute. Don't forget that lead coefficient must cancel out for this to work. So 2 times 2, and then x times x is x squared. Might as well get that right. 3 times 2x is plus 6x. And subtract. That minus that goes away. That minus a negative, 4x squared. This minus this is minus 6x plus 1. Last tier. X squared times what is 4x squared plus 4. Notice, squared, linear, and then finally constant term. So 4x squared, 4 times negative 2x is negative 8x, and 4 times 3 is 12, and we subtract. That minus that, gone. That minus a negative that, 2x. 1 minus 12 is negative 11, and that is the remainder. So that means that when we divide these two, the answer is x squared plus 2x plus 4 plus the remainder over the divisor, meaning what we're dividing by. So that would be the final answer, including the remainder. Okay, use synthetic division. Pretty straightforward. The one key thing to remember when you're using synthetic division, make sure you fill out any terms. So we got a cube term, squared, linear, constant, so that's okay. And this is the key one. This is a factor, x plus 6, which means that the root, or what we put here, is negative 6. So we bring the 2 down, and then we multiply. 2 times 6, negative 6 is negative 12, then we add. 2 times negative, hey, this is kind of repetitive, isn't it, is negative 12. Then we add. Now negative 20 plus negative, that's negative 32. Ooh, fun. Now it looks like we're going to get a remainder, right? Because these first 3 are going to be this, and then the last term is always the remainder. So negative 6 times negative 32 is positive 180, 192. And then we add, so it's 199. So that means our final answer is, now remember this is cubed, so this is going to drop 1 power because we're pulling 1x out. It's going to be 2x squared plus 2x minus 32 plus 199 x plus 6ths. Say that 3 times fast. And that is that, just like that. Okay, you can still do this. So we got a cubed, squared. So 3, negative 4, no linear term, then a constant. 3 halves. So this is x minus 3 halves, which means the root is 3 halves. So that's what we divide by. Fractions are your friend. Just keep saying that. Bring the 3 down, then multiply. Remember, top times top, bottom times bottom. So that is 9 halves. Now, negative 4 is the same as negative 8 halves. So when I add that, I get 1 half. How convenient. Then when I do 3 halves times 1 half, I get 3/4. then I add it, so I get 3/4, and this is going to be my remainder here. I don't think this is going to work out with no remainder. 3 times 3 is 9, over 2 times 4 is 8. 5 is equal to 40/8, so when I add that, I get 49/8, which means, remember, cube divided by linear is going to be squared, so it's going to be 3x squared plus 1/2 x plus 3/4 plus, now it's going to be 49/8 divided by x minus 3/2. The preference would be to actually simplify that. 3x squared plus 1/2 x plus 3/4 plus, remember, this, if I'm dividing by this, it means that this is the same as having a 49/8 times x minus 3/2. You could distribute this, so that means you'd end up with 8x minus, well, that'd be 24/2 or minus 12, right? You could even multiply this whole, you could actually pull a 4 out, but this would be more than adequate. The key thing is try to avoid leaving a fraction over a fraction like we have here. Okay, so now, use a graphing utility. So we're going to be, because this is k, this is kind of like saying x plus root 5 is one of the factors, right? That's what we're dividing by, which means we can use synthetic division. Cubed, squared, linear, constant. Now, just because it's a negative root 5 doesn't mean it doesn't work, okay? So I have to be willing to be a little bit patient. So I bring the 1 down, then I multiply. This is easy, minus root 5. Now, don't go decimal, because this ends up being 2 minus root 5, right? 2 plus a negative root 5. Now I'm going to distribute. Now, negative root 5 times 2 is a negative 2 root 5, and then negative root 5 times a negative root 5 is going to be a positive 5. Remember, the negative root 5 times negative root 5, negative times negative is positive. Root 5 times root 5 is, if you want, root 25, but it ends up being 5. So that's how I got the 5 there. Negative 5 plus 5, well, no roots, so that means that my result is negative 2 root 5, okay? Then I just multiply. Negative times negative is positive. 2 times, well, let's not worry about that yet. But what's root 5 times root 5? Well, it's 5 again, right? So I have 2 times root 5 times root 5, or 2 times 5, which is 10. That way when I add them, I get a remainder of 6. So what am I looking at? I'm looking at x squared plus 2 minus root 5, x, parentheses are kind of important there, minus 2 root 5, okay, plus 6 over x plus root 5, because that's the actual factor then, okay? That would be my final answer, right, like that. Okay, use the remainder theorem. So this is where you can use a series of thin synthetic divisions where you're dividing by these numbers. That is, these are factors. And then whatever the remainder is would be the result. So here we're trying to find g of 2. And so it's going to be 2, no fifth term, quartic, that is fourth power, no third power, that is a negative 1, don't be fooled. No linear term, there's a lot missing here. But what I'm going to be doing is a series of repeated divisions using, so this is A, right, these different things. So what I'm going to do is copy this because I know I'm going to need it. Over and over again. I'll have to modify a little bit here and there. So you bring down the 2, oops, okay, you don't do that, you use a little pen thingy. We're not going to have to worry about writing it out, we're just concerned with what the actual remainder is. So we bring down the 2, 2 times 2 is 4, add 2 times 4 is 8, add 2 times 11 is 22, add 2 times 22 is 44, add 2 times 43 is 86, add 2 times 86 is 160, 172, add this, our remainder, tells me that g of 2 equals 175, right? And then we just repeat that. So we're now going to paste our little thing because we can. And so we know that we're actually going to have part B here, and we're not going to be dividing by 2. But we're going to be dividing the same thing over and over again, so this is some good practice. So for B, we're going to do divided by 1, and then we add. 1 times 2 is 2, and we add. 1 times 5 is 5, and we add. 1 times 5 is still 5, and we add. 1 times 4 is 4, and we add. Times 4 is, and this tells me that g of 1 equals 7. And now, because we're dividing yet again, I'm just pasting this down here. I told you it was going to be the same thing over and over again, one line, right? Now we're going to do g of 3, which is probably going to be well, we'll see. We'll see what g of 3 is, which means I'm going to plug 3 here. 2 times 3 is 6, and add. 3 times 6 is 18, and add. 3 times 21 is 63, and add. 3 times 63 is 189, and add. There's 188. Ooh. Okay, 3 times 188. $564, and add. And now I need to do 3 times that. 12, 18, 19, 15, 16 is 1692, and add, which means that g of 3 equals 1,695. And that's right, ladies and gentlemen. One more time, because there's 4 parts to this. It's kind of a lengthy problem, but it's good practice. So g of negative 1. So that means we, once again, negative 1, always bring down the first, multiply, add. This times this is a positive 2, and add. Negative 5, and add. Negative times negative is positive, and add. Negative, and add. And then negative, so this is 4, and then we add. This is 7, which means that g of negative 1 equals 7. So a bunch of synthetic division. Okay, so using the factor theorem. So what we're going to do is show that x is a solution of the 1/3 degree, so this 3rd degree polynomial. In other words, here is the solution, meaning that's one of the factors. So this means one of the factors of this thing is x minus 1/3. So what we're going to do is we're going to take this cubic, there's no missing terms, which is kind of handy, and we're going to divide it by 1/3. Then we're going to take the result and try to factor the whole thing completely. So bring the 60 down. 1/3 of 60 is 20. Negative 89 plus 20 is negative 69. 1/3 of negative 69 is 23. Oh, sorry, negative 23. So that's 7, and then that means that our result here is 18. 1/3 of 18 is 6. Now, this is what we expected because they told us this is a factor. So the remainder is 0, which means we're now looking at a quadratic. 60x squared minus 69x plus 18, right? I now am going to factor this. Now, you could use a quadratic formula, but it turns out, because I know these are all divisible by 3, I can actually pull a 3 out, and I get 20x squared minus 23x plus 6, right? And then I can factor that, it turns out. So what times what is 6? And then also we need 20. So it turns out if I use 5x and 4x, this was a little bit of experimentation on my part. If I take 5 times, well, 6, I'm going to use 3 and 2. And because this is positive and this is negative, it means these both have to be negative. Now, if you distribute this out, it does work. So what this means is the final factored form for this original equation is 3 times quantity 5x minus 2 times the quantity 4x minus 3 times x minus 1/3, right? 1/3, right? Now we'd probably take this 3 and multiply it by this. That way you'd get a 3x minus 1. So it looks a little bit better. But either way, when we're asked to find the zeros, you know, this x equals 1/3, that first one given to us, and then solving these. So when is 5x minus 2 equal to 0? You add 2 divided by 5, that'd be a 5/2. And then here you'd add 3 and divide by 4, so that'd be 3/4. So then list all the real solutions of the equation. That would be that, the zeros. Okay. All right, so now A, verify the given factors. So verify that these are actually factors, meaning show that the remainder is 0. By the way, as we do this, we're going to change this first into a cubic and a quadratic. And then once we get the quadratic, we're going to be able to factor that or use the quadratic formula to find all the real zeros, that is real number zeros. So let's see how this goes. So first, we're going to have to divide. So 8, negative 14, negative 71, negative 10, and 24. It really doesn't make a whole lot of difference. Remember, this is x equals negative 2, and this is x equals positive 4. Let's go with the negative 2. So 8. Negative 2 times 8 is negative 16. It's negative 30. Negative 2 times negative 30 is positive 60. So that ends up being what? Negative 11. Negative 2 times negative 11 is 22. Minus 10 is 12. Negative 2 times 12 is negative 24, which means 0. Remainder 0, like we expect. We just verified that that's a factor. So now we're going to take this resultant, kind of just double down here, take this and divide it by the next root. So we've verified that this is a factor. Now we're going to do the same thing here. Bring down the 8. This is 32. This is then 2. 4 times 2 is 8, so it's negative 3. 4 times negative 3 is negative 12, and that is 0. So now what this means is we verified this is a factor, right? So far, let's keep a running total here. We know that we have x plus 2 times x minus 4 times, there are going to be 2 other factors there, right? And now we're going to take this quadratic and we're going to hope it factors. Let's see. So this quadratic is 8x squared plus 2x minus 3. So can we factor that? Let's see. So we know it's going to be negative, and it's going to be positive, and we got an 8. 8. I'm not sure this is going to work, folks. So let's scrap that and just go straight to the quadratic formula, which is still a valid way to go. So that would mean, and this sometimes happens, we know that the roots are going to be x equals opposite 2 over 2 times 8 plus or minus the square root of 2 squared minus 4 times 8 times a negative 3, which makes that plus, right? 3, all over 2 times 8. Okay, a little bit of simplifying. X equals, well, that's going to cancel, so negative 1/8 plus or minus, this is going to be over 16, right? 2 squared is 4 plus 32 times 3 is 96, so this is the square root of, it worked out. It was actually a decent square root, square root of 100. So that means x equals negative 1/8 plus or minus 10/16, or negative 1/8 plus or minus 5/8, which means we're looking at 2 roots. One, negative 1 plus 5, 4/8, or 1/2, and negative 1 minus 5, negative 6/8, or negative 3/4. So they want us to list all the real zeros, okay? So all the real zeros would be the first two, x equals negative 2 and positive 4, and then these other two we found right here, remember, from the quadratic formula, which would be 1/2 and negative 3/4. 4 zeros, quartic model, all is well and good. And yes, sometimes you're going to have to use the quadratic formula on these. Okay, so the last problem we're going to do is find all the real zeros of the polynomial function. Well, okay, looking at this, I see these all as divisible by 3. So to make this a little simpler, I'm going to rewrite this as 2x to the 4th plus 11x cubed minus 23x plus 10. The only reason I'm doing that is going to make the numbers a little bit more tractable, right? Now, I don't know what the real zeros are of this, so I'm going to have to kind of do a guess and check thing or graph it and hopefully find this. I'm expecting to find 4, we hope, right? So what I'm going to do is do some trial divisions. And by trial divisions, I mean we're going to take some educated guesses, and we're also going to read my handwriting correctly. Now, I'm screwing up right now because I did not account for the fact that there is no squared term, so 0, and then the negative 23, and then the 10. All right, here's to wishful thinking. Let's go ahead and hope that 1 is one of the possibilities. I don't think it is, but we'll see, okay? So 2, 1 times 2 is 2, that's 13, that's 13, right? 1 times 13 is 13, so that's negative 10. 1 times negative 10 is negative 10. And honest, no research ahead of time, but hey, there it is. That is one of the zeros. So I know that one of the zeros, let's keep a running tally, x equals 1 is one of the zeros. How did I get that? A lucky guess, to be quite honest. Okay, let's try negative 1. Now you could maybe pull another one out, I don't know. Let's see what you can get. So let's try negative 1, 2. So negative 1 times 2. By the way, full disclosure, I'm guessing again. Negative 1, 2, I'm just hoping that they're small numbers. So negative 2, that's 11. This doesn't look like it's going to work out. Negative 1 times 11 is negative 11, so that's 2. Negative 2. So you see a problem here, right? Now this is why we do math in pencil, because that did not work out. So that means we're going to go back to the drawing board. Maybe 1's another one. 2, it's 2, that's 15, it's 15, it's 28. No, that's not going to work out. How about, looking at the cubic here, some possible ones. Well, one possibility is negative 10 and 2, so maybe it's like, I don't know, negative 5. Let's try that. 2, so that's negative 10. So that's 3, right? So that's negative 3 times 5 is negative 15. So that's negative 2. Negative 5 times negative 2 is 10. So that actually, so we have another 0 here, is negative 5. And so now we got a quadratic. Now, what I did is I said, oh, okay, I got a negative 10 and I got a 2. What negative 10 divided by 2 is 5. I'm testing this out, that whole rational zeros thing. So I ended up with another root at negative 5. So far our factored form is, by the way, 3, don't forget the 3, right? Times x minus 1 times x plus 5 times, well, this is 2x squared plus 3x minus 2. Is that something that is factorable? I don't know. Well, it's going to have a 2x and an x, right? So I could do 2 times a positive 2, which would be a positive 4, and then minus 1. Negative 1 times 2, negative 2, negative x plus 4x. Hey, that's the factored form. So that means this is 2x minus 1 and x plus 2. So what does that mean? That means the other roots are, let's clean this up so I can actually fit them. So we know that we have negative 1, negative 5 from this division right here. And then what is that? That's going to be 1/2. And then this is going to be negative 2. They asked for all the real zeros. There they are. And that's what the factored form would look like. Okay? And that's it for section 2.3, at least the examples.